Hi everyone. Let's look at covalent bonds now. So I'm telling you here that covalent bonds are formed with electrons that are shared. So look at this example. I have 6 protons here. I have 1, 2, 3, 4, 5, 6 electrons. And that leaves me with these empty spaces for electrons, right? We've talked about that before. So what if you fill them up? In this case, this is carbon. And what if you used hydrogen that only had 1 electron in its outer shell, and we put it here? And we got another hydrogen and put it here, and it could share, and so on. We could take these hydrogens and each have them share 1 electron because this carbon has vacancies, right? And those vacancies need to be filled. So the diagram here is showing exactly that. So this makes everybody happy, if we can speak that way, where you have the hydrogen here now has 2 in its shell, so it is now stable. This hydrogen also, because it's sharing one of the carbon electrons, and sharing, and so if we add these up, we have 1, 2, 3, 4, 5, 6, 7, 8 in the outer orbital of this molecule of carbon. And so we have now just, made from this atom of carbon, we have made a molecule, and we've made that molecule that's called methane. And it's pretty stable. It likes that because it's got the correct number of electrons shared. And that's what makes a molecule. It doesn't mean you can't break it apart. You can. But in this form, this molecule is something that you know. It's called methane gas. That's what happens when carbon arranges itself with these hydrogens. And it becomes methane gas. Comes out of your stove maybe when you're cooking. Okay, so when we think of this kind of electron sharing, it's pretty well shared. It's like the hydrogen says, okay, I'll loan you 1, but you loan me 1. And it's this shared electrons in these orbitals. So they're going to hang out together in space because they want to be able to share those electrons. So going back a slide, that is what we're going to call a covalent bond. Okay, moving on, water. Water has covalent bonds because if we get H2, 2 H's, and an oxygen, oxygen has 2 vacancies in its outer orbital. So it can be sharing also with a hydrogen. So we could put 1 to share here, another hydrogen to share here, and we end up with H2O. And it's the same story as before. You've got 1 molecule, 1 atom that wants to share that electron, and it's able to equally share them. So water, when you make a molecule of water from its hydrogen and oxygen, is formed by covalent bonds. Okay. In water, the oxygen atom actually pulls the electrons more strongly than the hydrogen atoms. So you wouldn't see a hydrogen exactly in the opposite end here. You'd see it sort of more in this arrangement that we're seeing in this diagram. So we're calling it the Mickey Mouse shape because it looks like a face here with the 2 ears, which are the Mickey Mouse. Okay, that is going to indicate something called polarity. Polarity is very important for molecules because the outcome of that is that one end of the molecule becomes slightly more positive. The other end of the molecule becomes slightly more negative. Why? Because this oxygen was able to, with unequal force, grab those electrons with more force and hold them closer to the oxygen than they are to the hydrogen. In which case, because it's got negative electrons more close to it, it's going to be slightly negative. And these that have lost it a little bit are going to be more positive. Not totally lost, but they're kind of battling to keep that going. I'm going to stop that now. And the next one we'll talk about is an ionic bond.